So in this video, I'm going to go through a couple examples on graphing in standard form. So this first example, I have y equals x squared minus 2x minus 3. So one thing I'm going to start by doing, x squared minus 2x minus 3. So I know that my a value is 1, my b value is -2, and my c value is -3. So I'm going to start by finding my axis of symmetry, which will give me an x value, and that will be -b, getting ahead of myself, -b over 2 times a. So I'll have -2 divided by 2 times 1, which is -2 makes +2. 2 times 1 makes 2. So this would be 1. So for my axis of symmetry, my imaginary line is at x equals 1. So I'm going to come back to my graph, and I'm just going to make a dotted vertical line for the moment to remember that that's my axis of symmetry. Now, in order to find out where my vertex is going to be, I'm going to take that x value and substitute it into my original equation to find y. So I'm going to have 1 squared minus 2 times 1 minus 3. So this will be 1 minus 2 minus 3, which is really like saying 1 minus 5, which is going to give me -4. So my vertex coordinate is 1, -4. So I'm going to come back to my graph. 1, -4 is right there. So another thing that I can find, because of my equation itself, this c value is going to be my y-intercept. So I can graph the point 0, -3, which would be right here. Now, because of the symmetrical properties that a quadratic has, I can reflect this point over the axis of symmetry and get a point on the other side that I can use. And then last but not least, I'm going to find one more coordinate using an x value so that I have a total of 5 points. So I'm going to just see what happens when x is -1, and then I'll use that point to reflect to the other side. So I'm going to come back into my original equation, and I'm going to substitute in x equals -1. So I'll have -1 squared minus 2 times -1 minus 3. -1 times -1 makes +1. -2 times -1 makes +2, and then minus 3. And this will give me a y value of 0, so that coordinate is -1, 0. So I'm going to come back to my graph and graph -1, 0. And then I'm going to reflect that over, so it's 2 spaces away. So my other point would be 3, 0. And then I can connect these points to the best of my abilities and make it look like a parabola. So let's skip down to this next one here. I'm going to look at example number 3, y equals -x, x squared plus 6x minus 4. So I'm going to walk through that same process. I'm going to find my axis of symmetry first. Then I'm going to find the y coordinate that goes with my axis of symmetry. So my a value is -1, my b value is 6, and my c value is -4. I know I have to keep that c value tucked away in my brain because that's going to be my y-intercept. So to find my axis of symmetry, I'm going to look at -b/2a. So I'll have -6 divided by 2 times -1. So that's -6 divided by -2, which is going to give me a value of x equals 3. So that's that imaginary vertical line. So I'm going to come over here to where x is 3, and I'll know that all of my symmetry is going to happen around that vertical line. Now to find my y value that will match up with that x value. So I'm going to have y equals -3 squared, and I'm going to put the negative in outside of the parentheses because this is like having a -1 here that I'm multiplying after I do x squared. And then I'll have +6 times 3, and then -4. So this will be -9 plus 18 and -4. So -9 plus 18 gives me 9, -4 gives me 5. So I'm going to graph the point 3, 5 on my axis of symmetry. 1, 2, 3, 4, 5. I'm going to also graph the point 0, -4 because that's my y-intercept. And I'm going to reflect that point over. 1, 2, 3. 1, 2, 3. So I don't have x equals 1. I don't have a coordinate there. So I'm just going to substitute that in. So let's see what happens when x is equal to 1. So I'll have -1 squared plus 6 times 1 minus 4. Someday my camera will unfreeze. So this will be -1 plus 6 minus 4. So really that's like saying 5 minus 4, which would be 1. So that point would be 1, 1. So I'm going to come back over here and graph the point 1, 1, and then reflect that. So 1, 2, 1, 2. So now I have these points to connect. Again, to the best of your abilities, make it as U-shaped as you can. Close enough. So one reason that I know this is going to be upside down or inverted or reflected is because my A value is negative. Just keep that in mind. So the next one we'll look at is example number 2. So I've got 3x squared plus 12x plus 9. So I'm going to find A, B, and C. So this is 3 and 12 and 9. Now I'm going to go find my axis of symmetry. -b/2a. So this will be -12 divided by 2 times 3. So that's -12. Whoops, that doesn't look like a 12. -12 divided by 6, which is going to give me a axis of symmetry of x equals -2. So I'm going to tuck that out of the way for a second. Put my imaginary vertical line there just to keep that in mind where we're headed. And now I'm going to take that x value and substitute it into my equation. So I'll have -2 squared plus 12 times negative 2 plus 9. 2 squared is 4 times 3 is 12. 12 times negative 2 gives me negative 24, and then plus 9. So 12 minus 24 gives me negative 12, plus 9 is going to give me negative 3. So my vertex coordinate will be negative 2, negative 3. Here I know my y-intercept is 9 because that's that last value. That's my c value or my constant. So I have positive 9 up here. I'm going to reflect that over. Now because this coefficient is 3, I know my graph is going to be skinnier than if my coefficient was a 1 because these values are rising faster. So here I don't see anything for x equals negative 1, so I'll use that as a coordinate that I'm going to, or an x value that I'm going to use to find a coordinate. So we'll have 3 times negative 1 squared plus 12 times negative 1 plus 9. Negative 1 squared is 1 times 3 is 3. 12 times negative 1 is negative 12 plus 9. 3 minus 12 is negative 9, plus 9 is 0. So that coordinate is going to be negative 1, 0. So we'll have negative 1, 0, and when I reflect that over, it will be there at negative 3, 0. And now, oh Lord, attempting to connect these, good enough. You get the general idea. All right, and the next one we'll do is number 4. Now, I like number 4 because it's trying to trick you. So, my a value is negative 4. Come on, document camera. So my a value is negative 4. My constant is 8. There is no b value, so I know my b value is 0. So now when I go to try to find my axis of symmetry, I'm going to have 0 over 2 times negative 4, which is just going to be 0. So now my axis of symmetry is the x-axis. So everything is going to be symmetrical around my x-axis. So we aren't going to be able to use my y-intercept point as a point that I can reflect because when my document camera unfreezes, there we go, it's on the axis of symmetry. There's no reflection that I can do. So I have to find 2 other points now instead of just 1, and then use those points to reflect. So I'm going to do 1 and 2 as my x values, and then I'll use those coordinates to reflect. Oh, there we go. So when x equals 1, I'll have negative 4 times 1 squared plus 8. 1 squared is 1 times negative 4 is negative 4 plus 8, which makes this, oops, not negative 4. Come on, positive 4. So this coordinate will be 1, 4. So I can graph that. and I'll reflect that over. Then I'm going to do the same thing with x equals 2. So I'll have negative 4 times 2 squared plus 8. 2 squared is 4 times negative 4 is negative 16 plus 8, which gives me negative 8. So I'm going to graph 2, negative 8. So I'm going to go down to negative 8, and I'm going to reflect this over. I'm going to reflect it over here, and I'm going to connect these to the best of my abilities. So that's graphing in standard form.